My name is Nick Lotz. If you are here for the hands-on workshop for FiftyOne. If you are not super familiar with what FiftyOne is, this is definitely the place for you. If you are familiar with FiftyOne and you just kind of want to up level and get more comfortable with the platform, see what it can do, see how it can help you curate computer vision data sets, this is definitely the place for you as well. As I said before, my name is Nick Lotz. I work with the Voxel 51 community team. Um, and yeah, I'll kind of go into the logistics here in a moment. This is a 1 hour workshop. Again, thanks to everyone who has joined so far. Right off the bat, before I go into the logistics and the setup and what to expect, I do want to let you know that this will be a hands-on workshop. This is a QR code. This QR code links to the Jupyter notebook that we'll be using. The notebook file is hosted in Google Colab, which I actually should open up real quick. Give me 1 second here. Let's see if I can grab it without my screen messing up. And I'll throw the direct link into chat as well. This is probably worth doing. And particularly towards the second half to two-thirds of this workshop, this is what we'll be spending a lot of time on. The notebook itself is view only within Colab, just because compute. But you should be able to download it, run it on your system during and after this workshop as well. Couple additional things to note as we get started. In terms of the interaction, there is a Q&A functionality on Zoom. If you go to the bottom right of your Zoom toolbar and click the three dots, you'll see this Q&A panel. Whoops, sorry. I will ask if you use that Q&A whenever possible. The chat can tend to get pretty crowded if you use the traditional chat module. In addition to that, a colleague of mine, Burhan, is on the call as well. He is also a FiftyOne expert on the community team, and he's happy to help interact and answer questions as well. I'll kind of do my best to kind of keep an eye on the question Q&A panel also, but he's a good resource as well as questions come in. Okay. Without further ado, what I'm going to do is I'm going to start with a little bit of slideware. I promise we will quickly get into the hands-on portion of the workshop as well. Again, if you haven't copied this QR code yet or clicked on the link to the notebook in chat, I encourage you to do so. That at minimum will just be a great resource to have during and after this workshop. So, what are we doing here today? Well, first of all, let's sort of establish some level ground. If you are in the right place, if you work with computer vision data sets and are building AI models using visual data. So if you're working with unstructured data sets that are used to train neural networks, this workshop is for you. This workshop is meant to be an introduction to what FiftyOne is, its architecture, an exploration of its core capabilities. The overarching theme is data-centric AI. So the premise that we'll be working from is working through developing and managing computer vision data sets with the understanding that better data ultimately leads us to training better models. The focus of this workshop and the focus on FiftyOne in general is less so about model architecture. It's more on curating and visualizing and working with the data sets and end-to-end data pipelines used for training and evaluating models. Now, FiftyOne is ultimately an open source Python-based library. This workshop is focused more on the practicals of installing and using FiftyOne. It is less focused on computer vision theory. It's less focused on Python programming fundamentals. I deliberately wrote the notebook such that it is intended to be copy and pastable. Like there aren't too many tricks in the notebook in terms of like, blank spaces where you'll need to kind of fill in the blanks yourself. But that being said, again, this is more focused on applications of 51 to visual AI and computer vision versus kind of programming fundamentals or computer vision fundamentals. In addition to that, as I mentioned before, basically the framing of 51 and the framing of what we'll do here is the premise that data is very often the bottleneck to getting high performing models, whether it is not having models trained on representative data, whether those models have edge cases that they fail on, whether it's just understanding your data set in the first place, whether it's working with multiple modalities, such as, maybe video, 2D, 3D point clouds, spectrograms, geospatial data, often within a single data set that you need to manage. If you're working in a variety of verticals like automotive, healthcare, the idea is that you can curate a data set or multiple data sets and understand them better, and then ultimately understand what is going to help train better models in the process. Right. Couple final additional housekeeping notes here. This session is being recorded. If you've registered for this webinar, you will get some follow-up material afterwards. It'll include a recording of the session. There'll be some additional resources, the slides, the notebook, some additional like links to the 51 documentation and resources. Worth noting that this is not a direct certification path. So this is meant to be a hands-on learning workshop, but there is not a formal certificate that accompanies this. Finally, before we really get started, couple upcoming events. Tomorrow, there is for those interested in AI and visual AI and world models and agentic AI, there is a awesome workshop tomorrow led by our colleague Harpreet that's focused on visual agents. I think actually this slide is incorrect. It should say April 9th, 2026, which is tomorrow. But if you go to voxel51.com/events, you'll see a link to the event. For those that are Spanish speaking in the audience as well, we also have a computer vision meetup en Espanol that is coming up shortly as well. Again, you can see a list of all events coming up at voxel51.com/events. All right. All right, here is where we are going. So the goal is to get hands-on quickly. Before we do so, as I said before, there is going to be a few slides that I walk through in way of introduction and just kind of setting the stage of what 51 is, why do you use it, what's a little bit of kind of the data-centric AI concepts that we'll be introducing. Again, the framing here is that what are the core capabilities that we need when it comes to creating high-quality computer vision data sets. So we'll start with what is data-centric AI, and then we'll go into kind of the fundamentals of what 51 is from a architectural standpoint, what are its core capabilities of the SDK, what are some of the main classes, methods, routines that you would run, what are the core workflows for training, evaluating, and deploying models with 51. And then finally, it's something that I'm very excited to talk through is some of the integration that 51 has with LLMs, agents, skills frameworks, MCP frameworks. So especially if you are new to using 51, you might find the SDK and kind of the language that goes with it a little bit intimidating at points. We'll talk through the fundamentals of that in this session, but at the same time, a core part of today's workflows include integrating the software tools you use with agents that have context to understand them. So we'll go through integrating some skills that have been created with some of the core 51 workflows that we discussed. Again, we'll get to that later in the presentation and later in the demo. Okay, these first few slides are kind of salesy markety to be fully transparent. I will go very quickly through them and I'll just give you the highlights because we'll get into the technical meat of things quickly here. Long story short, there's generally a sense that with all the model architecture improvements that have occurred recently, data is still like the oil of AI in the sense that it is the core valuable asset that is needed for us to ultimately train better models. The better the data you have for training and evaluation, the smarter model you're able to create relative to the increasingly asymptotic and commoditized improvements of model architectures that have happened in recent years. And that tends to show up in the data, especially unstructured data. So when it comes to things like visual data, images, videos, couple things. First of all, unstructured data is difficult to filter and curate and understand because it requires metadata to assign meaning to it. Unstru Visual data is complex, right? When it comes, especially multimodal visual data. Are we talking about 2D images? Are we talking about 3D point clouds? Are we talking about um, uh, video frames? Are we talking about video timelines and action recognition? Are we talking about heat maps or sorry, spectrograms that might go as well with audio modalities? When we line them up in time series as well, that can be very difficult to organize and visualize and ultimately assign meaning to so that models can learn from them and can understand them. On top of that, unlike LLMs, visual data has a huge uh, labor intensive annotation requirement when it comes to establishing the ground truth that requires models to be trained in the first place, right? You literally have to tell the model, draw, in the case of object detection, draw a box around the object, and you actually have to assign meaning to that object in order to get to even give the model a starting place. So we found ultimately that machine learning teams spend an enormous amount of their time wrangling data. The long and short of it is it's been difficult to find a cohesive tool or platform that allows for uh, filtering the data, searching it, curating it, understanding what labels have been assigned to it, what our model training results are, what our different data set versions are. That's why 51 exists. It exists as a cohesive, unified platform. Garbage in, garbage out. If your data is bad, your models will be bad. Very important when your annotations are wrong on your data, that can silently degrade model performance because the answer key is wrong, right? When you supply incorrect ground truth, that can lead to catastrophic downstream model failures. So, how does 51 come in? 51 is as I mentioned before, an open source library that allows you to curate, annotate, evaluate models, visualize your data sets. It's extremely extensible. We'll go into that a bit, where there is an extremely extensive plugin ecosystem and operator framework that allows you to create custom integrations of virtually any type. When we think about how the 51 is organized as software, there's three core parts to keep in mind that we'll see. Number one is there is the core Python library, the 51 SDK that you run as a Python library. Number two is there's a library called 51 Brain that contains a variety of algorithmic methods to perform analysis on your data set. So for example, computing and comparing similar samples, computing and visualizing embeddings, generating uniqueness scores to find the relative uniqueness in your data set. Running model evaluations, that is comparing model predictions with the ground truth and computing things like F1 score, precision, recall, and so forth. And then finally, because this is critical to any type of working with visual data, when I use the term 51 app, this refers to a local web service that is served through 51 that you can open up, and it becomes a user interface to interact with the 51 program. It's a very common workflow is to interact with the SDK and then visualize those filters and visualizations and views that you created in the SDK inside the 51 app. 51 generally sits, therefore, between the intersection of work you do on your data and then work you do on your models. One way that you can think of 51 is it's like an IDE for developing visual AI data sets. Just like you use, VS Code for working with software development, 51 is meant to be your one-stop shop for curation, annotation, evaluation, and any other type of extensibility you might want to build into the platform. As mentioned before, 51 supports multimodal and visual data of all sorts of varieties. Um, what is especially powerful is if you see in the top left, there's a feature called grouped datasets that allows you to visualize multiple modalities within a single frame. So if you think about self-driving data, that's time series, you want to be able to take all of the different sensors that are working, and then the data from those sensors, you want to align them at a particular point in time. 51 allows you to do that here. If you look on the bottom, through 51's visual spectrogram support, you can also visualize, manage, and work with audio data in largely the same way you work with visual data. And then on the right, we can see again an example of 51's, in this case, geospatial integration. So here we see satellite images, and then we see it's kind of cut off, but we can see kind of the geographic representation on the right. Now, all of these views are in the 51 app. So it's that local web service that I mentioned earlier that 51 provides when you serve it in the application. Okay, so what are some of the core capabilities? So the core 51 library, as I mentioned before, is a Python-based library. Um, we'll do this in the demo here in a little bit, but it can just be installed through pip install 51. So the package is available in PyPy. And then the way you would generally get started is you would run something as simple as import 51 as FO or import 51 library. And then there's a whole host of built-in methods for things like loading your initial data set, then serving and visualizing your data set, interacting with samples. Again, we'll go into a lot of these here in the notebook in a minute, but just in terms of getting started, this is where you begin. Now, a couple things we'll note that I'll mention in further detail in a second is that the core open source 51 works fundamentally with local data sets, right? So notice there's a local path to your images. There is a similarly 51, depending on the format you're working with, it'll expect the metadata in this local path as well, associated with the image, and then it'll combine them together within the 51 app once it serves it. Worth noting that 51 does have an enterprise version. Again, this workshop is more focused on the open source, but if you're in like a large company and you want a more central client server model where your data sets would live in like, a central storage, a central object store, for example, 51 supports that as well. But if we're talking just about like local use, it would expect just a local file system path. Right. Give me 1 second here. All right. And as I said before, another core library, which you can also add with an import statement, we'll do this here in a bit, is what we call 51 Brain. So these are, again, machine learning powered routines for doing things like generating embeddings, dimensionality reduction, visualization, computing aspects, like I said before, like data quality metrics, uniqueness scores, similarity scores, what we call representativeness, which is like how representative of the broader embedding space a given sample is. Yes, and Burhan makes a good point. The enterprise version of 51 is a superset of open source 51. So anything that you can do in open source, you can also do in the enterprise version. And this really goes into the extensibility of the 51 SDK. So again, we'll see very quickly that we'll have a very, intuitive back and forth between running routines in the SDK and then seeing it visualized in the 51 app. So for example, when you're performing curation, you might run filter routines to create what's called views. The views might isolate the data set into a certain subset. It might sort the data by a particular criteria. You might try to use it to find duplicates in the data. You can filter labels in your data sets, and then you can label individual samples themselves through tags. Through now the native annotation interface, you can find incorrect annotations and annotation mistakes. So again, all sorts of data set management and curation you can do here. You can also aggregate statistics, visualize embeddings, um, perform interactive visualization, perform model evaluation, and then see charts of the metrics of, which we'll see in a second, of comparative comparisons between model runs. Again, precision, recall, F1, viewing confusion matrices of where there's sample level confusion. So again, these are all methods within the 51 library you can use, but at the same time, you can also compute again core model evaluation metrics and view them and compare them within the app. Okay, so from here, what I'd like to do is I'm actually going to skip ahead a little bit to the demo start. Give me a moment right here, and I will reshare my screen. And again, if you haven't taken a look yet, here is the QR code to the demo notebook. What I'm going to do is I am going to open my local copy of the notebook. And kind of everything I've discussed so far, we are going to get started working with the initial setup and dataset importation and initial dataset curation in 51. So step number one in this notebook, what I'm going to do is I have this set up where I can run these cells directly from the notebook for demonstration purposes. If you download the notebook locally, the first step is to install 51 dependencies. That can take a couple minutes. Just be sure to uncomment this line. If you're not comfortable with Jupyter notebooks, which I wasn't always comfortable with them, it also works where, if you have a Python environment set up, you can just copy and paste. Once we get into the Python code, you can copy and paste these lines as well in a Python shell. But for purposes of demonstration, we are going to start with just verifying that we can install and are using 51. So I'm literally going to run this first cell. And don't worry about this initial like red warning here. That's just a function of my Jupyter Notebook environment. We're seeing we are running 51. Here is the release of the open source version that we're using. So number two is we want to work with a data set. Now, again, if you're working with like real data in your work or in your research, you would generally have some kind of custom or bespoke data set that you're using in your organization or in whatever institution you're working with. However, for just working with 51 and learning about it and testing on data sets, and just using data sets to train like maybe generalized models, 51 has what's called a data set zoo. And what that allows us to do is with a single line of Python code, import one of dozens of public data sets that have been released. So these include the COCO data sets, these include ImageNet, these include the Berkeley Deep Drive data sets, these include the kinetics and action condition data sets. You can actually find these on the 51 doc site. So rather than needing to first like assemble all your data set with the right structure in your local file system, you can just run this load zoo dataset command from the 51.zoo sublibrary. And then if you include an argument of what data set to load from the 51 zoo, 51 will automatically pull down that data set, store it in the local 51 directory, and allow you to work with it. The zoo data set we're going to work with here is called Quick Start. And Quick Start is simply just a subset of the COCO 2017 validation set. So it's just a whole bunch of images with ground truth, with object level ground truth on them. There actually is a model predictions kind of put there as well in order to uh, set it up. And then we'll be able to get started. And just as a quick reminder, remember the first line of this up here is commented out. So uncomment it if you haven't yet pip installed 51. Yeah, if you're getting like module not found errors, that's where it would come in. But here I'm pulling down the data set. If it wasn't already downloaded, it will download it. It'll pull, it's not very large. And then we can see some of the core details about it. So we can see it is a 200 sample image data set. Here is the core fields that are associated with it. So again, this is an object detection data set. There is ground truth labels on it. There are also applied model predictions on it as well for purposes of this demo. The quick start data set that FiftyOne has in its dataset zoo comes preloaded with those model predictions. And then if we want to, say, examine an individual sample, we can just grab the first sample, and if we like run the print command on it, we can see all of the metadata on that sample as well. And this is, again, just being done so far through the SDK. And what this is all showing, this is showing the location of all of the object detection bounding boxes on it. But more exciting, if we then view this in the FiftyOne app, and then moment of truth here, we'll give this a second to load. Hopefully it does. There we go. This is loading inline in my Jupyter notebook. However, and again, I have this running on an external VM. If you're running this locally, it would be localhost 5151. So this is a public IP here that I have up here, but on your local system would be localhost over port 5151, regular HTTP. And this is fundamentally what the FiftyOne app looks like. So this is being served from FiftyOne. And then as we work with FiftyOne programmatically, commands and methods we run would allow us to create views that we can interact with in the app. So for purposes of some of this, I just have the exact same thing embedded here in my local notebook just to make it easy and not have to switch back and forth the whole time. So here, this is the quick start data set. So here we have what's called the sample grid of all of our samples. We have this sidebar on the left that allows us to filter different attributes of our samples. For example, we can toggle between showing bounding boxes for ground truth and predictions. If we create like label level tags, we can filter those. We can then importantly create what's called views, which is slicing and dicing our data set. And that's one of the first things we'll do here. So again, I can open individual samples and see the individual metadata for that sample as well. But let's say I want to start querying and curating my data set. So a core element of the SDK is this ability to create what's called views. So filtered, sorted, and sliced perspectives of the data. Some of the key methods that we use are this view field that lets us create a custom view within FiftyOne over any metadata field in the data set, and then operations like filter labels, match, and sort by to customize what the view looks like. So we can see what fields are available by examining the data set schema. And that includes things like our model predictions, a uniqueness score that was run and applied to the data set, the ground truth labels on the data set when samples were created. So, and then I think it's not showing classes here, but that is one. That is a built-in one as well. So for example, I might say, hey, what object classes are in our ground truth? So in this quick start data set, which is again a subset of Cocoa, it has the object classes, airplane, apple, backpack, and so on and so forth. It's actually, it's cut off here. This is alphabetically. There's much more than what is just shown here. And then what we can then do is we can say, okay, let's only show samples that contain person detections. So what we would then do is we would run this filter label method and match the ground truth to person. So when I say detections here, I'm talking about ground truth, not predictions at the moment. And then I'll create a view called, and I assign that to a view object called person underscore view, and then create a session view out of it. So if I then run this, we can see we have this filter applied at the top here. And then we can see there's now 94 samples out of the 200 shown, and all of these samples contain a person. Well, this llama, I guess, contains a person's hand, but you get the idea. Maybe let's now look at, we said we had applied predictions. Let's look at confidence scores. So the model predictions that were applied to this data set have a confidence score between 0.05 and 1. And let's filter by only showing high confidence predictions. So that'll be samples that have high confidence model prediction labels greater than, 0.9. 0.9. So I'll apply that. That creates, again, another view here. And we can see that the prediction field was naturally filtered automatically to show samples with predictions scores zero 0.9 or above. And we see that here. Now, something to note that might be worth kind of maybe questioning about a little bit is the logic of what I just did. It shows the samples that have, of any of the detections on the samples, at least one of them shows a high confidence prediction label. How can we kind of break this up a bit and like work with these individual detections individually, maybe treat them as unique samples? That's where we get into what's called patch embeddings, which allows us to reorient our sample grid so that, let's say there's a sample with multiple detections on them, which most of them have multiple labels to show different things. We can create individual samples for each of those labels and work with them discreetly. That's a really important aspect that we'll talk about here in just a minute. Just a couple more examples. We can find busy images, let's say more than 5 ground truth annotations. So this is a bit contrived, but it basically says if a given, sample has more than 5 labels on it, let's create a view out of that. So it uses dataset.match ground view detections where the length is of the length of is greater than 5 of the detections list. And then we can see again busy samples here. It looks like so 73 out of the 200 have more than 5 samples. And then finally, we can sort by number of predictions, maybe starting with the most predictions and then ending with the fewest. So now this is a sort method where the sample grid, is sorted with the highest number of predictions at the top. And as we scroll down, there's like fewer number of predictions per sample. All right. And then lastly, in this initial example, we can tag samples for later reference. So this is applying labels within FiftyOne to individual samples, so we can treat multiple samples as a nameable group. So here we create a filter, and we might call it low confidence label. So now we're saying, hey, we're filtering by predictions with a confidence of less than 0.3, and then we'll create a view out of that and call it just like a low confidence view, and then tag those samples with a low confidence tag. So if I then run this code and open the FiftyOne app with it, we can see that we now have this low confidence metadata. It's actually, okay, so here's actually where that patch embeddings that I talked about before would be helpful. It says 187 samples because each sample has many labels in it. So it's saying, okay, is there at least one label that is low confidence? But that can still be helpful here. We can see, let's see, label tags, no, sample tags. Let me go down here. We can see this sample has the low confidence tag on it. All right. All right, bear with me one moment here as I go back to the slides for a moment to talk a little bit more about what exactly we mean when we talk about the data set as a whole. So again, you'll notice that in the Python code, data set is an object. Think of it as a container composed of individual sample objects. So there's methods that you can apply on a data set, and there's methods you can apply on individual samples, and you can iterate through samples as well. You also notice that samples have custom fields. So you can store anything from numbers, strings, complex labels, bounding boxes. Those are all part of the fields that are applied to samples. In addition, FiftyOne infers if a sample is an image, video, etc., based on its file path within the FiftyOne directory in which the data set lives. And then finally, in terms of persistence, you'll notice that when I first started FiftyOne in the Jupyter Notebook, it said the data set is already downloaded. Ultimately, the data set is backed by a MongoDB database. So that's how FiftyOne stores the metadata for the data set. The unstructured samples themselves are files, right? This is unstructured image data, but the metadata is stored in a local MongoDB database. Again, in FiftyOne Enterprise, if you're like scaling up to like the organizational level, generally you would have an external MongoDB database that FiftyOne would interact with, but it's bundled together in the local Python package. Okay, so these are just some examples of media types. These include image types. Sorry, these are little faded labels here. Point cloud types, geospatial, video, DICOM for healthcare, grouped data sets. Is a real quick demo. I want to show you an example of a grouped data set just on a separate 51 deployment that I have, just to see what the samples look like. Hopefully this loads properly. It looks like this. So here's a good example of the Kitty self-driving data set. Here we have image data, we have different camera views up here, we have the 3D point cloud associated with it, and the alignment is based off time series, right? So this is a particular point in time, and it allows us to align samples together and work, or align different modalities together and work with them as a discrete sample. All right. So now that we kind of have a little bit of an understanding of what it's like to start interacting with our data set, I want to show you the next powerful aspect of 51, which is starting to use the capabilities in the 51 Brain library, and that is embeddings visualization. So the goal here is to take a more quantitative look at how our data set is organized through generating and visualizing the embedding space, which is a very common uh, activity you would perform in any type of computer vision workflow. On top of that, other brain capabilities like similarity computation, uniqueness computation, which I saw there was a question about that earlier, rely on embeddings to develop an understanding of the relationship of the different samples to each other in the embedding space. So what we're going to use now is we're going to use the 51 Brain library, which we've imported with the alias FOB or FOB. And then we're going to use the method compute visualization to generate embeddings at the data set. You can pass in an algorithm to use to generate embeddings. By default, I think we use UMAP. I think that's the default we use, but there's like sub arguments of the compute visualization command method that you can use. So here we're generating embeddings. We're generating the visualization. And then once this is generated, so take just a moment here. Yeah, it's using UMAP. All right. We can then view the embeddings panel in the app. Let me actually do this real quick before I do so. I'll open this separately. And if I open the 51 app, I shouldn't, and let me kind of reset my view here. I should now be able to see that I have an embeddings run, and then I can see my embedding space. Now, where does this become useful? First of all, I can put it side by side with my data, and if I just lasso a portion of the embedding space, I can see like the data that is the samples that are clustered together. Secondly, I can color code my embeddings by a particular attribute. So for example, by uniqueness. Samples that have a high uniqueness score, I can visualize within the embedding space and lasso that as well. In addition, I didn't apply it here, but if I had like labels, label color coding here as well, if there was like a cluster of cats that are like, I don't know, purple, and then dog labels are color coded as orange, and there's like an orange dot amidst the purple, that's a good example of like label mistakes that you might then evaluate and figure out, okay, why is my model thinking that this is a dog instead of a cat? And that's like an edge case you can start to look at, and then try to then train additional data uh, from that subspace of your data set. All right. And then especially useful is generating what's called object level patch embeddings. So all the embeddings we generated so far are at the overall sample level, right? But samples contain multiple detections. What can be especially helpful is generating patch level embeddings where you're basically creating one sample representation per detection. So if a sample has like dogs and cats and horses all in that same sample, you can create it'll basically appear as a dot in the embedding space for each of those samples. And then you can get more granular view of like, okay, here is where the model is zeroing in on this particular object in this particular sample. So patch embeddings zoom in at the object level. You do that by passing in this patches field is to like what object field or what object, what object detection field you are generating the embeddings based off of. So here, this is a really good way to evaluate the quality of our ground truth annotations. So here I'll generate patch embeddings. Again, it'll take just a moment as this goes. And then I'm actually going to go, before I go back to the app, I'm going to go to the next example as well, because this will create the patches view within FiftyOne, where we can now see an individual sample or for each detection. And notice there's like repeats in terms of the frame of like the image frame, right? So like there's this food frame that had a bunch of detections on them, but each sample is now like zeroed in on an individual detection, like broccoli right here, right? So there's now one detection per sample. And I should be able to now go to the patches view. Yeah, there we go. So this is what the patches view looks like. And I can color by, say, ground truth detections by label, right? And again, my screen real estate's getting a little bit constrained here. But this is where I can be like, okay, looking at different clusters, are there any outliers? Like, do I see a bunch of dogs clustered amongst cats where the model where there might be a labeling mistake in the ground truth. I can cluster by confidence score. Actually, no, I can't. I don't think I generated embeddings based off of that. I apologize. Um, but yeah, this is a really useful way to get sample level views when there's multiple bounding boxes per sample. And then now that I have embeddings computated, I can build a similarity index over the patches so we can view and automatically look for similar samples that might be clustered together. So I'll then run this compute similarity method. And what I can then do is after I do this, when I open the app back up, I can literally select a sample, click a button in the app, and then it immediately rearranges the sample tile grid to show similar samples by descending level of similarity. So it'll show most similar samples first. So now, if I go back to the app here, if I, let's say, let me click on this bear here. If I then click this sort by image similarity and click show similar samples, based off that similarity search computation, I can see similar samples. This is kind of funny. For whatever reason, there's a little bit of food here that thinks is similar to the bear. For whatever reason, we can say here's a bear, here's another bear, here's a dog, cat, animals. Again, this is a pretty diverse data set. So, but you get the idea. All right. For the sake of time, I'm not going to go too far into six. I will leave six here as an exercise for the reader. Six here is based, and then I'll move forward to a couple other things. Six here is based off of research Voxel 51 has done to in taking a large data set, finding the samples that are in most need of labeling. So it's basically a special way of computing uniqueness using what's called zero set core set selection or zero shot core set selection. It's basically given an unlabeled data set, is there an algorithm that I can just one shot and it'll report back what are the samples of that data set that are most worth labeling based off their relative uniqueness in the data set to get broad coverage for what the model is being trained on. Again, I'll leave this section as an exercise for the reader for the sake of time, but this is another good way to, if you don't have any labels to start with, how you might kind of import into FiftyOne the data in the first place that could then be labeled. All right. Speaking of labeling, give me one moment, real quick. FiftyOne now has built-in annotation capabilities. This is relatively new since around February of this year. Um, we have 51 has always integrated and still does with external labeling tools like CVAT, Label Studio, and others. Again, it's very extensible in that way. But as of a couple months ago, the native app now includes built-in annotation as well that can be used for greenfield annotation as well as correcting labels. And the idea here is to label smarter, not harder, like using the things we've learned about so far. Um, Finding the places in which ground truth labels need to be corrected based off low confidence, based off being the odd man out within the embedding space, we can immediately go in and adjust our labels as needed. So what does this actually look like? Well, if I go into the 51 app here and I click into any given sample, like maybe this sample here, I'm going to deselect these for the moment. So here we have a sample of two dogs. You'll notice that alongside this explore pane is this annotate pane. And this annotate pane allows us to add a custom schema as a new label field, or it allows us to use an existing schema. So for example, we might say, hey, I found that our ground truth detections are wrong, and I want to adjust them. So now if I go back, whoops, sorry, one second. Ground truth, 5 attributes. Give me one moment here. I always get the order of operations wrong on this. Give me 1 second. Yeah, there we go. Okay, I need to actually select the field. So now let's say for whatever reason, let's pretend that like, one of these was incorrectly labeled, or maybe it actually needs to be labeled, or maybe this was like incorrectly labeled as a dog, or maybe the bounding box isn't quite as tight as it could be. You can adjust the label as needed. This again, this is the Cocoa data set, so this looks fairly correct here. You can change the label if needed to something else. If I need to, I can create a new label. So again, if this was like an actual animal here, I could select it and apply the label. And then again, this will get saved into my existing label field with the schema that it has. Now, again, this isn't really a dog, but just for the sake of this example, that's what you would do here. So again, this is a really good way to QA possible incorrect ground truth in your data set. All right. And then once you feel okay, cool. Quick note as well, just as a quick aside, in 51 Enterprise, there is built-in auto labeling through attached GPU compute. So you can also use vision language models to perform AI-based assisted labeling as well. We call that auto labeling in the enterprise version. If you look up some of the tutorials on the 51 docs as well, there are also ways you could do to zero-shot labeling within the app. It's not quite as or within the open source version. It's not quite as UI native, but that can be a really good way to like generate an initial set of labels, which you can then QA. All right. All right. So looking at time, there's, I think, two last things I want to walk through here. Definitely, which will be inference and evaluation. And then I also want to make a shout out to 51 skills and how that works with 51. I might give a little bit more of a cursory look at the dashboard aspect, just because I'm looking at the clock here. So how then do we then bring in our models? So again, you can easily apply your own model using, any integration or Python integration or PyTorch or whatever library you want to use to apply your model to a 51 data set. The 51 model zoo also, like it has pre-curated data sets ready to use, it also provides pre-trained models ready to use. So in this example, we're going to use a faster RCNN model to add an additional field of predictions to our data set. So we already had kind of a predictions field already, but this is like, hey, we have a new model. We want to apply the model to the data set, run inference on it, and then store the predictions in that data set. So here we're loading the model. So we're going to load ResNet. And then this is a small data set, so inference won't take very long. So it's going to perform inference on the data set. And then we are going to, and we'll notice then we're storing the results and a new label field called um, zoo preds or zoo predictions. And then after that, the kind of big kicker of this is then we'll compute core evaluation metrics, precision, recall, F1, which is again just basically just comparing precision and recall of the model to ground truth. So now we see this new field here. If I click it, it's getting a little bit busy, so I'll uncheck the other ones. But these are now the prediction fields that the model is applying against this. So we say, hey, it's an airplane. Now, quick note, when applying a zoo model like this, there might be some schema differences that can poison the precision recall F1. So for example, like airplane versus plane, for example, if ground truth calls it plane and the model calls it airplane in the world with the world model, that's like, well, that might be interpreted as a different label. So there might need to be some like sanitizing you do there. Um, Ideally, the model is um, compatible with the ground truth. So now if I evaluate detections here, give me 1 second here. I can see my screen. Let me reshare. My screen was getting a little wonky there for a moment. There we go. The view should be better now. Okay. So we evaluated detections, and now if we explore the results here, first, I've generated a view where the model potentially made incorrect predictions. So I was sorting by false positives in this example. But more helpfully, if I open up this model evaluation tab and put it side by side with the data set, I can look at the model results and look at quantitatively what the model results are and look at class level performance. So here's metric performance, confidence, IOU, precision, recall, F1, which again is just harmonic mean in precision and recall. I can see class level performance. And again, this is kind of a constrained view here, but I can actually like drill into like, hey, like I can look at just my bird samples, for example. And then finally, if I look at the confusion matrix, this is there's so many diversity of samples here that the confusion matrix won't look particularly interesting, but this shows where different classes of data might have been confused. And again, that's unlikely here just because there's like so much diversity of objects. But if there are things that are similar, like, car, truck, bus, for example, you could actually click on the sample where the confusion might be, and it'll only load those samples. So here it's showing, all detections of car and the samples that have them. But if there is a disparate cell in the confusion matrix that was like where horse interacts with, dog, for example, it'll show where the model confused horse with dog. So this allows you to filter out some false positives. All right. So when it comes to, again, using the FiftyOne app, we're kind of closing the loop here of um, again, curation, annotation, model evaluation. And I want to fully make it clear that, if this is your first time using the FiftyOne library, it is very SDK driven. It's very software programming language driven. You see the result in the UI, and there's a whole lot you can do to customize the UI. One thing we don't have time for today is like creating custom dashboards in the UI. That's pretty straightforward, so I don't want to, but I'll leave that as an exercise to you all. It's in the notebook. But one thing I do want to spend a little bit of time on here at the end, in the last few minutes before we take questions, is on um, FiftyOne's integration with AI assistance. So let me reshare here. So over the past several months, we've been increasingly developing skills that can be used with tools like Claude, Codex, other Gemini, other tools. And these skills combined with what we now have as a, FiftyOne MCP server, it provides the context needed for tools like Claude and others to just quickly onboard and interact with your data sets. Using a common set of workflows. So this is just taken from the current state of the README in the FiftyOne skills repo, and we can see that The skills that we have include importing data sets, exporting data set, performing inference on them, model evaluation, embeddings, visualization, again, allowing our AI assistants to do that, again, if we're kind of building familiarity with the SDK. So it's just a couple of examples here. I'm going to skip down to 51 skills with Claude Code, and fingers crossed that I did this, that the demo gods have favor on me here, because I'm trying to get to embed some of the Claude Code results here. So here I have Claude installed, and I should have this setup step includes the commands using Claude to like add the 51 MCP server and plugin. I've done this already for the sake of time, but if I now run Claude plugin list, we should see, yep, here we find some of the 51 skills that I've installed as plugins. So dataset curation, embeddings visualization, finding duplicates, model evaluation. I see the 51 MCP server should be there as well. Yep, it's connected. I have that locally. And now again, really, if you're familiar with like AI tools, these are just providing lots and lots of extra context. So the AI is prompted to go about the workflow the correct way. So for example, if I then find duplicates in the quick start data set, this is prompting Claude to use the appropriate skill to find duplicates. And we should see a result here in a moment as it churns and runs. Hopefully it'll show up here in the notebook output if we give it a second. Doo, doo, doo. And let me see if the other one runs as well. I'm running it in headless mode and it worked a moment ago. Hopefully it'll work again. I'm worried it might be hung up. Again, we'll give it just a second here. Yeah, the demo demons strike again. Ah, 5, 4, 3, 2, 1. Oh man. Okay. Darn it. Um, I was trying to be a little too clever by half by having this embedded in the notebook. Sorry about that, folks. I'll hang on this another moment. It could have just been taking a while, but I'm thinking, let's see. Should have run. Yeah, I would need to debug this. Yeah, the demo demon struck here. Sorry, folks. That being said, the 51 skills repo is a really good way to get these installed. We have what I'll do is in the follow-up to this workshop, I'll direct you to a talk that was recently done by one of our colleagues, Adonai, and he did a pretty detailed walkthrough of getting the 51 skills set up and then showing you again what this is doing is this is Claude just operating on 51 and kind of performing actions directly on the 51 app and then adding some additional context and recommendations as well. All right. And I wanted to show this. Sorry about that, folks. I'll collect some additional resources. That being said, we are coming right at time here. That being said, still, this is a really good way, once you get this working, unfortunately, this is a really good way to onboard onto 51. If again, you're still kind of developing some familiarity with the SDK. Hey, here we go. Demo 2 worked. It just took a while. Okay. So, yeah, so I think this just took a while here. Here's a good example. So on this one, it said analyze the class distribution and label quality of 51 quick start, provide three specific action curations. So this is more recommendations than actually performing an action in 51, but we can see it analyzed the data set, so it had the skill to do so. We can see the class distribution. Again, there's a severe imbalance of persons there. As we can see, here's the label quality, and it used Claude skills to filter and curate the data set to supply these metrics. And then it gave some recommended curation actions. And again, you can prompt Claude as a result to be like, okay, like perform these actions, and then it'll run those, Python commands against the data set. Okay, so I'm glad one of these worked. I was hoping it would actually like I'd get the duplicates here, but I think again, it might just be a little bit of stepping on each other going on. Good. Okay, so this ended up running okay. Um, cool. All right. So where do we go from here? One second. I'll take questions here in a moment. That just about finishes up the workshop demo that I wanted to give. I have a couple of additional QR codes here. I would say that, if you haven't done it yet, I unfortunately should have had it directly here on the slide, but I haven't put it here. Is if you have not pip installed 51, if you have just been kind of following along and kind of exploring a bit in the notebook and the documentation and watching this, pip install 51, again, it installs as a self-contained unit. Join the 51 Discord community as well. We have a highly active community on Discord. If you have any, questions there, you are more than welcome to ask those there also, and just interact with other users of 51 and other computer vision practitioners. And then finally, I mentioned earlier, voxel51.com/events. We have lots of exciting upcoming events coming up, both virtual and in person. That's a great place to just kind of have a more synchronous way to devote time to learn and explore what's going on in 51 and what's going on in just the industry and ecosystem as a whole.